All right, so this is the first lesson of trigonometry. So trigonometry is all about right angle triangles. Okay, so triangles that look something like this, where one of their angles has a little square in the corner, meaning that this is like a 90-degree angle. Okay, so all the things that we are going to do have to be done on a right angle triangle where so one of the angles in that triangle has to be 90 degrees. Otherwise, this stuff doesn't work. All right. So the first thing that we're learning about is something called Pythagorean theorem. So this sounds nonsensical at the start, but it'll make sense in just a second. So it says the square of the hypotenuse is equal to the sum of the squares of the other two sides. So that probably doesn't make a whole lot of sense just yet if you've never heard about this before. First thing that we're going to talk about is what is the hypotenuse. So the hypotenuse is just one side of the triangle, and it is the longest side of the triangle, and that is always right across from the 90-degree angle. So here's the 90-degree angle, and the hypotenuse is always like directly across from that one. It is the side that does not touch the 90-degree angle, and it is directly across from it. Okay, so that is the hypotenuse. Often we're going to use HYP to be like an abbreviation for hypotenuse. All right, so then it says the square of the hypotenuse. When it says square, okay, it's talking about putting an exponent 2. Okay, square means when you multiply something by itself. So 5 squared means the same thing as saying 5 times 5. Okay. Why we call it 5 squared and not just like 5 exponent 2 or something like that, why we say square is because 5 times 5 is like a square that is 5 tall and 5 wide, and that would give you the area inside of this square, right? So like length times width is the area for a square. So 5 times 5 is 25. That's the area of this square, and so we say like 5 squared is the same thing as 5 times 5, which is 25. Okay? So when we say the square of the hypotenuse, that means if we took the length of this hypotenuse and multiplied it by itself, so like c times c, or whatever it happens to be in this triangle. Down here we have the hypotenuse here, 7.4, so we times it by itself. So if we square that, it's going to be equal to the other two sides squared put together. So let me just draw you a quick visual example of what that looks like. So here is a right angle triangle. I can do my best to do a 45 degree. That's not bad. Okay, and let's say I have this side is 3 centimeters long, this side's 4 centimeters long, this side is 5 centimeters long. Okay. So when it says the square of the hypotenuse, that's like taking this 5 and squaring it, like times it by itself. So I'm going to just draw a 5 by 5 box coming off this side of the triangle. Okay, so I mean like this length is 5 and this length is also 5. Okay, so inside here would be 5 squared, right? 5 times 5, the area of that is 25. All right, now these other two, if we square them as well, so 4 times 4, okay, I'm going to draw a 4 by 4 box here. 4 times 4. The area of this square kind of looks like it's 4 right now. I'm just going to move that 4 out of the way. It's right there. 4 times 4 is 16. And the square of this side is 3. It kind of looks longer than the 4, but bear with me. A 3 by 3 box. The area of that one is 3 times 3, which is 9. So what we have here is that this is 25, and that is the same as these two boxes put together. 9 plus 16 is 25. Oops. 9 plus 16 is equal to 25. This works for any right angle triangle. So it doesn't matter which like weird right angle shape you have, if it's rotated on its side or if it's stretched in a super weird way, as long as there's a 90-degree angle, this will work. Okay? And I have kind of an interesting little example here. So this is just something I 3D printed, which is that same diagram that I just drew. Now, I know it's not the easiest to see, but what this is a triangle that's got sides A, B, and C. C is the hypotenuse there. And I have the square of B here, and I have the square of A here. And if we put those two squares together, we take those two areas and we put them together, it will be the same as this c squared side here. So, sorry, if I take this, move it over to the c, now I'm going to take the area of A and kind of unravel it here. There, you can kind of see that a little bit better. If I unravel it to go around C or B, okay, together, the area of those two things makes c squared. So this is how we're going to figure out, if we know two of the sides, we can figure out what the third side is by using this relationship. So if I was given C and A, the way I could find B is by taking the area of C and subtracting off the area of A, and what I'm left with is the area of B here. This is the area of B. So hopefully that doesn't make it more confusing, but now I'll show you what this looks like when we actually do the math on our page. All right, so if we go down to this first example, the example asks us to find the missing side in each triangle to the nearest tenth. Okay, so we are looking for this side. I'm going to call this side C because C is the side that we use for the hypotenuse. So A and B can be either of the two legs of the triangle. Okay, the legs are just the sides that are not that longest hypotenuse. So A and B could be either one. I could call this A and this B, or I could have done it reverse and called this one B and this one A, and the math doesn't change, that's totally fine. But I have to call this one C. So the hypotenuse is always C, because that is the longest side. So I'm going to call this side C, and I'm going to call this one side A, and I'm going to call this one side B. So now I need to find out the length of this side, and I can use this equation. So I say A squared, so A was 4, 4 squared, that's just 4 times itself, plus B squared, B is 8, so 8 squared, is equal to C squared. Now, be careful that you cannot just add this 4 and 8 together before you square them. You can't just say 12 squared right now. Okay, it's a common mistake, but if you try it in your calculator, you'll see that you get two different answers. So what you need to do is you need to say 4 squared first. So you can either say 4 times 4, or there is a square button on your calculator if you have a calculator that looks like this. Okay, 4, and right here is a squared button. So it's like a little X with a 2 beside it squared. Okay. So 4 squared is 16 plus 8 squared is 64. So it's like the area of that one was 16. The area of this square was 64. And together these are going to add up to C squared. So now if we add them together, we will have 80 here. So 80 is equal to C squared. Remember that this is not our final answer. Okay, 80 being C squared, that's like the area of that square around here. What we need is we need just the length of one side. So what we do is we have 80 is equal to C right now. Or sorry, 80 is equal to C squared. We need to get rid of this square. The way we do that is by square rooting. Okay, the opposite of squaring something is square rooting. And so we are going to square root this side. That basically is, yeah, it's just the opposite of like multiplying it by itself. And let's square this side. All that this does is just gets rid of the square. This side just kind of cancels out and we're just left with C over here. And in your calculator, you just have to do square root 80. So this is not anything that you have to do on paper. There is just right above the square button on your calculator, there's that little square root sign. So often you'll have to hit like second or function or whatever your button is to get it. And so I'm going to say square root 80 on my calculator, and it tells me 8.94. 8.94. So I know square roots are something that we don't use as often. It can look a little bit intimidating, but really it's just one more button you're pushing on your calculator. Square root 80, and it gives you 8.94. So what we just did is we said that 4 squared plus 8 squared gave us 80. Okay, that is the area of like the box here. Then we square rooted it to find out what's just the length of this side, and that is 8.94 is the length of this side. Now, this is the other kind of example. In this case, we are starting off with the hypotenuse. Okay, this side right here, this is our hypotenuse, and we want to find out what is this side. So remember that our hypotenuse is always C. So this is C, and I could call either one of these A or B. I'm just going to call this one A and this one B. Let's go reverse. I think people more commonly do it this way. Okay. So this time I have this one, and I have this one, the big one and a small one. I need to find the other small one. So what I need to do is take the big one and subtract the small one to get what's left. So instead of saying these two things together make the big one, we're going to say C squared subtract A squared, right? The big one subtract the small one is going to be equal to our other small side. Okay, so if you're given the hypotenuse, you have to take it and subtract the other side. If you have the two other sides, that's when you just add them together. So let's just plug in our numbers now. This becomes 7.4 squared subtract 3.6 squared is equal to b squared. So we're just going to put that into our calculator. Remember that you need to square it first before you subtract. So 7.4 squared subtract 3.6 squared is equal to 41.8. 41.8 is equal to b squared. Okay, and your answer is not done yet. Okay, we have found b squared, but we've not found b. So that is like the area of this side was 41.8, but we need just the length. So we square root it, square root. That just leaves us with b. These two things cancel out. And on our calculator, we put square root 41.8 and get 6.47. I'm going to round 6.47 as our final answer. Okay, and now we are done this side, or this triangle. We've solved that this is 6.47. Final answer. Okay, and this is, all the problems are going to look like this. The only difference in this next example is just that it gives us a situation, and so draw a triangle to show what they're talking about here. So this one says like the bottom of a ladder is placed 3 feet from a wall. So to start off, I'm just going to draw a wall. Okay, and here's the ground. So here's a wall, here's the ground, and it says the ladder must be placed 3 feet from the wall. So I'm going to go, let's just say this is 3 feet. That's where the ladder is going to be placed. The ladder is 12 feet long. How far above the ground does it touch the wall? So it's leaning up against the wall. And we said that it's 3 feet away from the wall, and the ladder itself is 12 meters long. So we want to know, what is this? So this is a right angle here, straight up and down wall and straight across floor. And so now it is just figuring out what this side is. So this is our big side, our hypotenuse, across from the 90, our hypotenuse. And this side I'm going to call B. So I'm going to call this is C because it's our hypotenuse, and this one I'll call A. So we're going to take our big side, our hypotenuse C squared, subtract off our small side, B squared, and be left with our A squared there. So C is 12 squared, subtract B squared, that's 3 squared, is equal to A squared. So 12 squared is 144, subtract 3 squared is 9, is equal to A squared, which brings us to 135 is equal to A squared, and now our final step is just a square root. Square root 135, square root. These two things cancel, so we're left with just A, and if you do square root 135 on your calculator, you get 11.6. 11.6. And one way you can, one thing that's good to check is that your hypotenuse is always going to be your longest side. So if you ever find your answer of one of these sides is bigger than your hypotenuse, you must have done something wrong. So we found out that the height is going to be 11.6, and that makes sense. This ladder is not going to go up further than its own height. Okay, this is smaller, so there we go. The only extra things in this one is just one. This one says the legs of a triangle. Okay, that's just the two shorter sides. So I'm not going to go through the whole thing. I think I'm just going to put the solution up and leave it there. But this one also asks you to find the area of the triangle. This is not really related to what we were doing. It's just kind of like an extra question it's asking you, kind of like a review question in a way. So it says two sides of a right triangle are 8 and 12. It says find the area of the triangle if 8 and 12 are the legs. Okay, so 8 and 12, because it says they're the legs, they're the two short sides, and then this is the hypotenuse. I'm going to call this one 8 and this one 12. This one asks us to find the area. So we actually don't have to find the hypotenuse at all here. We just need to say 8 times 12 divided by 2, right? Base times height divided by 2 is the area of this. So that's going to be 48. Okay, 8 times 12 divided by 2 is 48 inches squared. Now it says find the area of the triangle if 8 and 12 were a leg and a hypotenuse. Okay, so if 8 has to be the leg because the hypotenuse has to be the longest side, and if this was 12. Then we need to solve for this side, and then once we know this side, then we can say base times height divided by 2 and find our area there. So I'm just going to put up that solution. All right, so the way I found this was that I took my big side, subtracted my smaller side. 12 squared subtract 8 squared is equal to 8 squared. Then we needed to square root it to get 8.9. So we found this side out to be 8.9 inches. Then to find the area of this triangle, so the space inside, we take 1/2 base times height again. So that is just 1/2 of 8 times 8.9. And that will give you the area of this triangle. And that works out to be 35.6. So let's say 35.6 inches squared is our area of this triangle here. So it ended up being a little bit smaller than this triangle here. The area of that one was 48 inches squared, and the area of this one was 35.6 inches squared. So just be careful if it ever asks you to find an area that you remember that, okay, we're talking about the inside of that triangle. It's kind of like a separate thing than the Pythagorean theorem, but we can use it to kind of figure those things out. So the practice problems are very much just a squared plus b squared is equal to c squared, or you just take the c and you subtract the b to get your a. So good luck on this one, and I'll see you in the next one.